Welcome to the session on exponentials and logarithms, the laws of logarithms. The objectives for this session are to recall and apply the laws of logarithms. Recall exponential functions. They are functions of the form f of x equals a to the power x, where a is a constant. The inverses of exponential functions are called logarithms. So the exponential relationship where a does not equal 1, such that a to the power x equals n, can be written in terms of a logarithm as log n base a equals x. Let's derive some results from these relationships. If a is greater than 0, then x equals 1 implies a to the power 1 equals n. And therefore n equals a. And in particular, log a base a equals 1. If x equals 0, then a to the power 0 equals n. Therefore, n is equal to 1. And in particular, log of 1 base a equals 0. If x equals minus 1, then a to the minus 1 equals n. Therefore, n is equal to 1 over a. And in particular, log of a to the minus 1 base a equals minus 1. Let's now look at the multiplication law. Log m base a plus log n base a equals log mn base a. The division law. Log m base a minus log n base a equals log m over n base a. The power law. Log n to the power k base a equals k log n base a. Let's prove the multiplication law. Let x equal log m base a and y equal log n base a. Then we have, if we rearrange, a to the power x equals m and a to the power y equals n. Therefore, m times n is a to the power x times a to the power y, which equals a to the power x plus y. Therefore, x plus y equals log mn base a. However, we know that x is log m base a and y is log n base a. Therefore, we have that log m base a plus log n base a equals log mn base a. Now let's prove the division law. Let x equal log m base a and y equal log n base a. Then a to the power x equals m and a to the power y equals n. And therefore, m over n equals a to the power x over a to the power y, which equals a to the power x minus y. And therefore, x minus y equals log m over n base a. But we know that x equals log m base a and y equals log n base a. And therefore log m base a minus log n base a equals log m over n base a. Now let's prove the power law. Let x equal log n base a. Then a to the power x equals n. And therefore, raising this to the power k, we have a to the x to the k equals n to the power k. And therefore, a to the power xk equals n to the power k. And so, log n to the power k base a equals x times k. We bring k to the front, and x is of course log n base a. And hence we've proved the power law. Here's a summary of the results. We can derive some more results from the power law. In the power law, let k equal minus 1. To give log x to the minus 1 base a equals minus log x base a. Let's have a go at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example 1 part A. We are required to express log 2 base 4 plus log 6 base 4 as a single logarithm. So let's solve this. We are going to begin by using the multiplication law, since we're using the same bases and we're adding. Log 2 base 4 plus log 6 base 4 equals log 2 times 6 base 4, which equals log 12 base 4. Now let's have a go at 1 part B. We are required to write log 18 base 3 minus log 2 base 3 as a single logarithm. Let's solve this. We're going to use the division law. Log 18 base 3 minus log 2 base 3 is equal to log 18 over 2 base 3, which equals log 9 base 3. And now for part C. We are required to write 2 log 5 base 8 minus 4 log 3 base 8 as a single logarithm. Let's solve this. We're going to use the power law and the division law. First, let's apply the power law. So 2 log 5 base 8 becomes log 5 squared base 8. And 4 log 3 base 8 becomes log 3 to the power 4 base 8. And so applying the division law gives us log 5 squared over 3 to the power 4 base 3. Which equals log 25 over 81 base 3. And now for part D. We are required to write log 8 base 10 minus log a third base 10 as a single logarithm. Let's solve this. We are going to apply the division law as shown here, and then tidy up to give us log 24 base 10. Now let's have a go at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example 2 part A first. We are required to write log p cubed q squared r base a in terms of log p base a, log q base a, and log r base a. So let's solve this. We're going to apply the multiplication law, as shown here. And then the power law, here, here, and we don't actually need to here, it's just left as it is. And hence we have the expression in terms of log p base a, log q base a, and log r base a. Now let's have a go at part B. We are required to write the expression in terms of log p, log q, and log r. So let's solve this. First apply the division law, as shown here. And then the power law to each term. And hence we've expressed our expression in terms of log p base a and log q base a as required. And now for part C. Again, we're going to apply the division law as shown here. And then apply the multiplication law to this term. And log r to the 5 is left as it is. And finally we apply the power law here, here, and here. And hence we have our expression in the required format. And finally for part D. Let's solve this. Again, we apply the division law, as shown here, and then apply the power law to the second term. So log q base a stays as it is, and log a cubed base a becomes 3 log a base a. However, we know that log a base a is equal to 1, so let's tidy up. Log q base a stays as it is, and 3 log a base a simply becomes 3. Now let's have a go at another example. Pause the video and have a go. Press play when you're ready to view the solutions. Let's solve this. We are required to solve log 4 base 12 plus 2 log x base 12 equals 2. Let's rearrange, firstly by applying the power law to the second term, here, and then the multiplication law, as shown here, and then re-express this log in terms of powers, as shown. And then solve for x. So x squared is now 144 divided by 4, or x squared is 36. Hence x equals 6. Now let's have a go at another example. Pause the video and have a go. Press play when you're ready to view the solution. Let's solve this. We are required to solve the equation log x plus 17 base 10 minus log x minus 1 base 10 equals 1. We're going to begin by applying the division law, as shown here, and tidying up, or rather re-expressing in terms of powers, then multiplying out, and expanding, and finally rearranging and solving gives us x equals 3. This brings us to the end of this session. If you have understood its contents, you should be able to recall and apply the laws of logarithms. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.